Good morning, everybody. My name is Jerry Lowe. I'm the head of advertising and marketing technology at AWS. Welcome and thank you for joining me today in discussing best practices. Today we're going to cover 4 broad areas: measurement and analytics, real-time advertising, customer data and identity, and innovation with machine learning. So let's dive right in. I believe in 3 truths: death, taxes, and there will always be more data. So, data velocity, data volume, data spikiness, more frequent, higher spikes, data changes, and of course, my favorite, delivering data in near real time or real time. So these are all data challenges. So how do we best address that? Let's look at 2 ways that we can do that today. As you can see in this example, there is quite a bit of variance between the average and the peak. So how can we best deal with this? When we look at this diagram here, on the left-hand side, we actually see a typical data center on-prem deployment. First, you have to provision enough servers to cover your average load. Then you add some more to actually make provision for peak. And finally, you actually have to add some more to provision for growth during the time that you actually deploy your new capacity. On the right-hand side, you can actually see what that same workload would look like in the cloud. And specifically here, because you can actually auto-scale, which means you basically just deploy the compute instances that you need when you need it. You can scale up and down. And in this case, we're actually going to look at 2 items that can actually help us to further improve that. The one is containerized workloads, and the other one is serverless compute. So let's take a look at that. As you can see, first we decoupled the functions in this workload. On the right hand, you can see the transformation functions, and we further isolated that so that we use Spark SQL to provide standalone isolated Spark nodes, right? And this enabled us to actually scale vertically and horizontally. And we run this on an EKS cluster, a managed EKS cluster. And then on the right hand, you can actually see the dispatch feature, basically transmitting that data to our customers. And we actually deployed that using Lambda features or functions. So when we actually do this, what it enables us to actually do is to react to any incoming workload in terms of volume. But it also enables us to react to any changes in that workload, because we can simply go to the specific feature and then modify or change that. Or we can actually add a new feature and change that. And so being able to scale horizontally in terms of features and functions and vertically in terms of capacity is then the result of this containerized workload and Spark isolation. When we actually look at the dispatch function, it brings its own set of challenges. And specifically, just because you can now scale seamlessly, we should be careful not to flood our customers, right? They may not be able to react that quickly. And so you have to build in a throttle function in that delivery feature. Specifically, what you can do is to actually look over the history of successful deliveries and then use that to actually determine what your future throttle capacity should be. When we look at the second item, is setting the retry limit in your jobs is actually critical, because now you have the capability. If you set it too short, jobs will keep on retrying. It will immediately spin up more features, more instances, or more functions. And then, it will keep on retrying that job. So it's critical that you actually avoid that. And the way that you would do that is to actually implement a heartbeat in your features, in your functions, so that you can get a heartbeat, let's say, every minute. And what you would do is, if you miss 3 heartbeats, you would restart the job. And let's say you set a secondary limit. If you miss 3 heartbeats, you would simply sideline that task and leave it for special investigation. So, you know, a couple of hard lessons learned: when you actually improve your architecture, you also have to think about how it will impact downstream. So what is the outcome of actually isolating, you know, your Spark features and functions and then running these Spark pods? As you can see on the right hand, it reflects a typical Spark cluster, which is a fairly static size, right? And it has two negatives. The one is, if you have two jobs competing for the same compute or capacity, either one will take precedence and go first, and the second one will be delayed, or both may be delayed because they're simply running slower. When you look at the right-hand side, using this on a containerized fashion, you would simply spin up more containers, more compute, to actually deal with a specific feature, so there would be no delay. In addition, you have a more granular scaling mechanism. And so that then leads to the saving that's reflected there, 55%, not insignificant. So this is really a pattern that I can highly recommend, specifically for data ingestion that's very spiky. The next area that we want to explore for best practices and innovation is real-time advertising. It's one of my favorite areas. Specifically because, you know, here we deal with significantly high volume. You know, our biggest customers deal with 800 billion plus transactions per day. It's 30 million per second. And it has to be processed in less than 20 milliseconds each. Excuse me. This, in addition to the fact that you have to do this at very low cost, really makes this a very interesting problem space. And some of our customers are really innovating in a significant way. So let's actually go to my number one and most favorite recommendation today, which is Graviton 2, right? That's our new ARM-based instance. And I would simply say this: if there's one thing that you do today, is go away and experiment. Try out Graviton 2 for your workload. The process is fairly simple. Just try it. Now, when we actually look at Graviton 2, it is just one of almost 400 instances that we have in AWS today. So when we look at this specific use case here, we will look at the moment at the specific parameters that they consider. But let's think about this. If you have to transport 60 people to a destination, you will use a bus. If you want to go and buy groceries, you will most likely use the family car. In the same way, I urge you to experiment in trying different instance types and sizes to find the one that fits specifically for your job. Right? So let's take an example of parameters that's being considered. In this case, the trade desk had two very distinct workloads, essentially back-end and front-end workloads. And in the front end, they had a large number of small objects that they needed to process and access. And primarily, this was done in a read-write, almost balanced fashion. And so what that meant is that they wanted to get as many of those objects and the indices for those objects in memory. So there was a specific ratio of memory to disk that they needed to establish, and that led to the selection of the i3EN instances. On the back end, they had much larger objects and more write predominant workloads. And experimentation there then actually led to the selection of M5D metal instances. What is significant here, this was specific to Aerospike, and Aerospike is one of our significant partners. So the key here is how they went about experimenting and testing this, not just for a few minutes, but actually running a test for a day plus to really determine that everything from memory to actually hard disk had the throughput and the performance that they actually required. So the best practice here is go out and experiment with different instance types and then test them. It can have a significant improvement on your cost performance ratio. Another item that you should remember is in the cloud and in AWS, we deliver new instances roughly once every year. And now with Graviton 2 that we own and develop ourselves, that will be more frequent. And every time we actually deliver a new instance type, it is typically at a lower cost point and a higher performance point. So simply trying out new instance types, you can get a significant cost reduction. So I would urge you to keep an eye on that and do try the new instance types when they come out. Finally, when we look at our architecture, especially when we do a lift and shift, the first step that I would urge you to do is to actually migrate or refactor your application to be cloud enabled or cloud native, and specifically to make it stateless, because stateless unlock two important things for you. The first one is with stateless, you can actually then deploy auto scaling, and that will actually reduce your cost so that you only pay for what you use. So that's very significant. Number two, it will then enable you to actually use spot instances, and spot instances will further reduce your cost over on-demand or even reserved instances. So, that can be a very significant saving. Now, what we see is that customers in general are pretty conservative. So they will use 20, 30, 40%. But as you can see in this use case, the customer really leaned forward and they actually deploy almost 80% of their instances as spot instances. And I would actually urge you to go and even increase that further. Look at your instance advisor so that you can actually determine what your fallback mechanism would be. If one instance type is not available, what is the next one that you will fall back? Number one, so instance fleet. Number two, look at the spot availability in your actual region and in your zone, because that will give you an indication of how probable it is that a spot instance may be removed. But be aggressive in this. It can make a significant impact on your platform. Next, we are going to look at customer data and identity resolution. Right? So this is really about data engineering at scale, massive scale. And with a loss of identifiers coming soon, this is a workload that will actually take on a significant importance if it hasn't done so already. So let's take a look at what we can do. As you know, this is a fairly complex and comprehensive problem set. You have to ingest data, you have to connect to different sources and ingest that. Then you actually have to determine how you will unify multiple IDs into a golden ID. You actually have to transform that data so that various consumers have it in the right format. You may have to conduct analytics on it, both for analytical purposes, but also for machine learning, and then you have to store it. So when we actually look across the various silos, be it ingestion or harmonization or resolution, or analysis and delivery, data processing is a significant component on that. So let's actually take a look at how we can improve that. So the first topic is, format matters. And I literally mean, how you actually store this. So in this use case here, in MapReduce jobs, simply changing the format in which the data was stored from a text-based format to ORC or columnar format, say that twice quickly, it reduced the EC2 consumption by 69%, not the storage, the actual EC2 consumption. So that was pretty significant. Secondly, when we actually look at data ingestion, data processing, these are typically tasks that are discrete jobs, which lends itself very well to auto-scaling. In this case here, you can actually see, they were able to achieve a 60% plus cost reduction, right? So for me, the three key items in data processing, data pipelines, is really auto-scale, run it on spot instances, and on Graviton 2. So each one of those will actually have a significant impact in the range of 30 to 40% each. And you can just imagine what the cumulative impact on your workload would be. Next, let's look at storage. So when you actually look at storage and you have several terabytes or maybe hundreds of terabytes or petabytes, storage actually matter a great deal. So number one, apply a life cycle policy for your storage. Simply use tiered storage, and at the least use intelligent tiering, and that way you can actually learn a lot about how your storage should be tiered without any risk. The second one is reduce your data retention. Simply stated, if you currently keep data for 3 years, if you can reduce that to 1 year, it will be a 66% reduction. And I would further suggest that you actually work with your business partners and actually make them responsible for the cost of data retention. I am assure you it will change the outcome of that conversation. And then finally, partitioning of your data is important. So in this use case here, simply by partitioning data by date range, for the same date range, enabled Presto to improve performance by 20%, right? Now, be it a date range or any other parameter, it can significantly impact the compute that you need to apply in processing that data. So, careful analysis of your storage, how you store, the actual format, how you partition, how you tier, and how you retain can significantly impact your data storage cost. So when we actually look at the identity load itself, when we look at the processing of that, consolidating a large number of different identifiers, in that processing, we typically run loads like Amazon EMR Spark clusters. And the first recommendation there is to actually run that, of course, on Spot instances. And it's now available on Graviton too. So EMR Spark clusters with Spot instances and Graviton 2 can make a significant difference in that workload. So let's talk a little bit about innovation. So innovation alone is not enough. But at the same time, I should say that innovation is required for your business to survive. Simply, if you don't innovate, your business is already busy dying. But you need speed in association with innovation, because if you deliver too late, it simply won't matter. And speed requires intent. It is not something that a company obtains by accident. It is a willful act from your side to actually implement and establish speed. So actually, let's take a look at how we can drive innovation and speed with machine learning. So the challenge that we have with machine learning projects, and I would pose to you here that the machine learning project is the same as any other software development project. It has a life cycle. It is just machine learning, a different topic. So the challenge that we have with machine learning is that currently we are spending 80+% on the heavy lifting of data selection, preparation, data engineering, setting up infrastructure. And these are repeated tasks that we do every time that we run the load. And we spend very little time actually addressing the core problem, the challenge, the machine learning or data science problem. So how do we actually go about that? Looking at the challenges that we have here with very large data loads, right? The infrastructure that we have to create, the skills that may not be available, and the other tiers of model sophistication and performance. My number one recommendation would be, before you start your machine learning project, pick a machine learning development environment. Let me ask you this. Who of you actually built his own car versus just buying a car and driving it? Or develop your own EDI versus just picking an EDI for your development environment? Or in a similar fashion, develop your own CI and CD pipeline instead of just picking one off the shelf to use. So we should stop you doing that with machine learning. Pick a machine learning development environment, implement that, and then automate as many of the steps as possible in that process. It will deliver great results for you. So the second one, a recommendation for machine learning innovation, is simply this. So AWS provide the right tools for the job. I would even go as far to say the best tools. And in this case, my strong recommendation is that you actually try SageMaker. So when we look at the lessons learned here, and we look at the steps along a machine learning model, right? When we look at data selection and engineering, right? We now have SageMaker Data Wrangler that can help us to select and aggregate and prepare our data, be it data selection, data cleansing, exploration, or visualization, right? There's a tool that will actually help you do that and to automate that step. When we go to feature engineering, there's SageMaker Feature Store. So, this enables you to actually do the engineering for a feature once and then place it essentially in a library, and you can reuse that and you can share it with other teams. So you only have to do that work once. And then when we get to the selection of a model, the typical process is you would actually try a model, set specific parameters, run it, look at the results, and then come back and maybe change some of the parameters or change a different model. Now, with SageMaker Autopilot, you can actually run multiple models. It will run a lot of permutations. I would say any permutation for you in terms of hyperparameters, and identify the best performers for you so that you can then focus your effort on a small subset of models and parameters that you can then further fine-tune. So, these are just examples of what's available in SageMaker. So I would highly recommend that you look at SageMaker as your machine learning development framework, where you have all of these features and the ability to automate under one pane of glass. So let's look at what is the outcome when you actually select a framework like this. In this case, Freewheel selected SageMaker. They were able to reduce their resources used, by 60%. And furthermore, reduce their cost by 50%. Significant results in both cases. But I would actually, pose to you that the biggest achievement here was because they were faster to market, faster to actually turn the wheel. They were able to do more experiments, and more experiments is more likely to lead to success. So, and it also reduced the risk. When you have experiments that are done faster, it's less investment in each experiment. So other customers have found, results as great as from 8 months to 4 weeks. And then subsequent iterations of that model, taking days, because all of the steps in the pipeline is automated. So I highly, highly recommend this. So what are the takeaways from today? Number one, really go out and try Graviton 2 today. If there's nothing else that you do, try Graviton. Number two, refactor your application, your platform to be stateless. If you haven't done so already, it enables auto-scaling and spot instances. And then try out containerized workloads and serverless functions. If it's applicable, remember, not all workloads is applicable or useful for containers or for serverless. And then finally, accelerate innovation, get speed in terms of machine learning projects by using Amazon SageMaker as your machine learning framework. So that is it. Thank you very much for your time today. I really appreciate it. I want to give a big thank you also to the people that shared their use cases that we had here today. It enabled us, all of us, to learn. If you have a significant use case, please do email me. So thank you very much. Have a great day and stay safe.